Show a demo of a game of making a 3D game that uses Java as its language, which is a lot like you could say C or C++, but it has more modern features. And one thing I like about it is that it builds a lot faster as well. So I'm going to go ahead and build. This is in debug. I just want to show that I filed in less than a second, which is really nice for iteration speed. But another thing I want to point out here is that we have command line procedures that were found, and so this is these are some warnings due to updating the compiler, and I'll fix those later. But this is output from some of my code generation, so we'll come back to that later. But in any case, we're going to actually do a release build, so that because I want to show. I'm going to show a little performance bar, and I don't want it to read lower than it really should. And yeah, about 10 seconds is fine, and it's a full build. There's no incremental building with this compiler, so we'll go ahead and run. Keyboard here. All right, so we've got third-person controls here with a little left side offset, sort of like Shadow of the Colossus. One for there. And we can also switch over to a first-person view, and we can pick up this ball because it's kind of in the way. And we can also press this button, and this button and this big door here in this door as well are what I call gadgets. And gadgets can have children, and children can, or parents to children can essentially interact. So, like a gadget, when it's done doing something, it might interact with one of its children, which is going to be part of the game that this is becoming eventually. So you can see when I press the button, it opens this door, which opens this door, which is this button. So this is a loop. And you might have also noticed I've got a little developer UI. And so here's my free camera, and I can use my mouse. You can also move things around. So I'm going to pick up this ball, and physics are enabled here, so it falls back down to the ground. I can also ball really big, which pushes the guy out of the way, and I can make it small, smallish. We can also got a little basic spawning system here, or at least the beginnings of it. So I can spawn a few stacks of balls just to mess around with. And if I go back into one of these perspectives, here we go, first person, I can pick up this ball and I can open them. It's here. Yeah. There we go. So it's got all that stuff. It is definitely a real video game and all that. The physics I wrote, it's not my own. The concepts aren't mine, but I did write the physics system, and it's, I think probably the physics is pretty close to where it needs to be in order to support, probably years of development, maybe at least a year. So the next thing I want to show is I've got more dev UI stuff. Pretty floaty camera here. So we've got a performance window about bringing to full opacity. We've got log into full opacity. And if we get this out of the way, you can see I've got the green bar here. If you can see that, is the 240 frame per second mark, I believe. And then the yellow bar is 120, and then the very top is 60. So if we made it to the very top on, a development build, that would not be good. I'm trying to, the goal is to sort of at least keep it under the yellow bar, and then if it gets, too far, basically green is the target for the end. Also, these are tiles. I can move these tiles around, but we'll come back to that. Player community as well. So earlier, I showed that there were command line stuff. So one of the command line procedures that was found during code generation was save world. So what I'm going to do is type save world, and see I've got autocomplete, and here I can tab and it'll autocomplete to save world. hit enter. And over on the right side, you can see here it says saving world. I mean, it's very tiny text, but the world was saved. And then what I'm going to do is I'm going to mess with things a little bit. I'll move this ball over here. In fact, I'll go ahead and drop all of these balls off to infinity. Oh, well, okay. It looks like that is a bug, but we're going to go ahead and probably destroying one of those things is causing a bug here. And I haven't worked on this in a bit, but instead of making a new video, we're just going to demonstrate that things really do work. So what was the name of the world? Let's say it. 2754. Okay. So we can get back to that. And we're going to load world 2754. Boom. There we go. And we've got the world exactly it was before the unfortunate crash. And let's see. Yeah, see everything's still in a loop, just as it was before. All of the states are put back exactly as they were. You can still false. Okay. Okay, so that is, say, most of the features. One thing I want to show is that the world serialization, obviously, it needs to be able to serialize references. Otherwise, how would these things refer to each other? And the world serialization is also backwards compatible. So I want to go into the code just a little bit here. We're going to blow this up. And this is the I've actually done a few takes, but this is the first time I've gotten to this point. So figure it out. World here. Look. Anyway, so the way world loading and saving works, I figured, is actually you could do versioning, as in you could every time the world changes what it could possibly be, as in this definition of things, like if you need to add a new array of stuff, whatever it is, you might change the version, and then say the v4 also saves an extra array and also loads that extra array. But that seemed not so great to me for supporting really rapid development. So my thinking was, instead, why not think of the world format more of as an interpreter, or it's sort of a network format with header data, right? So the header in this case is an enum. So the enum, essentially, the way it works is you encode an enum into the file, and then you encode the data related to that enum directly after. It also, you're also allowed to encode subroutines, so you can encode loops into the loading, so that you don't have to encode repetitive data, like the number of entities. Your save function here is not dependent on the number of entities. So, for example, here at the end of, see, this is a save world right here. Okay. So we're going to skip all this, and this is actually where serialization of the file begins. But we can skip down to this part where essentially here we're serializing a subroutine of saving all of the entities, basically. So that we come down to load, you can see obviously save is sort of hard coded, and that you need the save function needs to know what the world is. But in the load function here, so we're loading the world. The load is actually just an interpreter. So main operation is serialize, blah, 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 and then we go ahead and encode end of file just to make sure that it's valid at the end of the file. So mistaken, it should be deferred. Right here, yep. So at the end of saving, we serialize end of file so that we can read it at the end of this interpreting. If we go to serialize, here. All it is a big switch statement where each code, each header, each whatever you want to think of it as. So if you think of it as interpreter, then each of these is a code that corresponds to some data, which might be a process or whatever. And if you're thinking of it as network data, you can think of the world ID, for example, as a header. And so the header tells you how to load the ID, right? Tells you what the next thing is, which some of it is just, serialize this thing, right? So it's quite simple. Some of it is not. Some of it requires, like, for example, meshes. Each entity can have an array of meshes. So the meshes need to be referenced. So the references need to be serializable. So there's a little bit more to it with mesh data, right? So when entities are serialized, yeah, slightly more complicated. But for the most part, it is just read what the thing is, and then serialize that thing. And this function works both for loading and saving, which is why it's just called serialize. Yeah. So I just wanted to show. I feel like I hadn't really put enough work into showing what this project is and how far along it is, because I think it's actually, quite representative of my ability to make systems level stuff. In any case, thank you for watching. I'm going to end the video.